Welcome back. Where does she get the haircut? At the barber. Okay, so let's get into it. We have got this new topic, curve sketching. Okay, geometrical applications of calculus. You can call it this, you can call it that. Essentially, we're going to be sketching using the derivatives. Okay, now the first lesson that we're going to really talk about is we're going to talk about this idea of a function being increasing, decreasing, and also stationary at different points. Now, what this means is the terms relate to the gradient of the tangent. Okay, so as you remember, we've got these 5 points here, and we're going to draw the tangent at each of these points. Remember, tangent only touches once, so that would be a tangent there. That would be a tangent there. That's your tangent there. That one doesn't even touch, but you get the idea. And that one there. Okay, so essentially, without going too deep into it, you can kind of see that some of these tangents are positive, some of these tangents are negative, and some of these tangents are zero. Okay, that's the idea here. Now, I'm going to come back to this concept and we'll kind of talk about that. But one thing that you need to understand is your original function, your first derivative here, and your second derivative, they all tell us different things about the curve. Okay, your first derivative just tells you whether you're positive or negative. Your second one, your first derivative, which is probably the one we're looking at today, it tells you whether we are positive or we have a positive or negative tangent. Okay. And your f double dash x, we talk about concavity. We will cover this in a little bit more in depth in the next couple lessons. Okay, now I know this is looking quite intense, but like I said, yeah, we're going to cover mainly the first derivative and the second derivative. Okay, now whether it's negative just kind of means negative. If it's zero, it means it's zero. If it's positive, it means it's positive. That's probably as easy as it should make sense. Okay, but when we start talking about the first derivative, we can see that if your first derivative is less than zero, we can say that your function is decreasing. Okay, now note, it's not the f dash. We're talking about the original function itself. It's decreasing. But if your first derivative is zero, then we call that stationary. If it's greater than zero, then we say it's increasing. Okay, now remember your first derivative talks about the gradient of your tangent. Okay, now there's also your f double dash. We'll cover that more in depth in a couple lessons. Okay, so if I've got an example here, we want to state where the following function is positive, negative, increasing, or decreasing. Let's take a go here. So let's take a look at A. First of all, is it positive or is it negative? It's definitely negative because it's below the x-axis. And if we talk about in terms of the tangent, it's actually increasing. Okay, hopefully that makes a little bit of sense. If I'm talking about B, it's above the x-axis, so it's definitely positive. Okay, but if I talk about it being, if I look at the gradient of the tangent, it's definitely negative tangent, so we'd say it's decreasing. Okay, C is an interesting one. It's definitely negative because it's below the x-axis, but take a look. We have got a zero. We've got a flat tangent, so we're going to call that stationary. Okay, I'm going to leave those last two for you guys to complete. Hopefully this is starting to make a little bit of sense of how we classify these points. Okay. Now, this is probably where you're more likely to see the questions. They'll give you a function. They'll say 4x squared take away 2x. Now we want to find whether it's increasing, decreasing, or stationary at these 3 points. X equals 3, x equals a quarter, x equals -1. Okay, now looking at these words here, these are definitely talking about the first derivative. Okay, I'm not talking about positive or negative. I'm talking about increasing, decreasing, or stationary. Just as a quick reminder, we're talking about our first derivative. Okay, so here's what I'm going to do. I'm going to, first things first, I'm going to do my derivative. And deriving my fx, I should get 8x minus 2. Okay, now at x equals 3, I'm just going to do f dash and substitute in 3. So it's going to be 24 because 8 times 3. Take away 2, that's 22. And this number here is positive, which means my function is increasing at that point. Okay. In terms of b, I'm going to do f dash of a quarter. And so I'm going to go 8 times a quarter, take away 2. So 8 times a quarter is 2, take away 2, that equals 0. Therefore, it's if your first derivative equals 0 at the particular point, it means it's stationary. Okay, and the last one didn't leave quite enough room. I'll do it up here. I'll say f dash of -1 means that I have 8 times -1 minus 2. That calculates to give me -10. And that means it is, because it's a negative number, we say it's decreasing because we're talking about the first derivative. Okay, hopefully that makes sense. And let's do this one last one. We want to find, for this example, we want to find the values where your function here is stationary. Okay, so key word here, if it's find the values, essentially we're solving for x. Okay, we're looking for the x, or we're looking for the unknown, or whatever the variable is. Okay, now if we've got stationary, this is where you start to need to get it into your head. Stationary means f dash x should equal to 0. So let's do that. We've got fx right now. First step is to find f dash x. Okay, so doing that, we should get 3x squared plus 18x minus 48. Okay, and again, to find your stationary points, we let f dash x equal 0. So I'm going to write that down. Okay, so 0 equals to 3x squared plus 18x minus 48. Okay, now at this point here, it's a quadratic. I need to solve, and I'm going to take out a common factor here. And looking at this, I can see that it's 3 bracket, 2 things that multiply to give me 16, should be 8 and 2. So it's going to be plus 8 minus 2. Okay. And again, we're trying to find the values. So in other words, we're solving for the values of x. So we know here, we can see that x should equal to minus 8 and positive 2. Those are the values that when x equals -8 and x equals 2, that's when that graph is stationary. Okay, I hope that helps. I'll catch you guys later. See ya. Bye-bye.